So section 4.1 was introducing us to our angle measure in a way of a circular kind of a rotational thing. The idea of radians, the concept of radian measure. Oh, one other comment I'll make that I've noticed on the quiz so far. Pi is not a unit, right? Pi is a number. Pi is 3.14. It's equivalent to 180 degrees in a conversion, but pi is not a unit. So I noticed some people putting like pi per minute or something, like that was a thing. It's radians per minute. Pi is a measure of radians, but it's just a number. Pi is just 3.14159. Okay? So I noticed some of that where it looked like people canceled a pi with a radian or something strange. And so anyway, pi is a number. Pi is not a unit. Radians is a unit. Now, sometimes we just leave off radians or it disappears or whatever, but it's okay. But anyway, so we can talk more about that on Monday. So the trig function. So you're familiar with sine, cosine, tangent. And now in geometry, did you do anything with those bottom three? Did you talk about those at all? No. Those look familiar? Okay. So so we have sine, cosine, and tangent, right? You did all three of those. You did the old SOHCAHTOA stuff, right? Now, what does this mean? Sine is opposite over hypotenuse, and cosine's adjacent over hypotenuse. Tangent is opposite over adjacent, right? It was just a ratio of the sides of a triangle. So historically, trig has been introduced in two different ways, or thought of in two different ways. So one is the right triangle ratios, which you worked with in geometry. We will do some right triangle trig, what we usually call right triangle trig. Okay, but also it's thought of as unit circle coordinates, which is what we're getting into. So we've been talking about the circle, we've been talking about pi 6 and these degrees, and now we can do the sine of. So you remember geometry did sine of 60 degrees. For example, let's just write one down here. So a geometry scenario would look something like this. This might be 60, this might be 30. You remember the ratios of those? You remember the relationship of a 30-60? I'll give you a hint. One was across here. Remember these at all? This is 2. Well, you just do Pythagorean theorem at this point. Root 3. And then for 45 triangles, geez, I'm going to talk to our geometry teacher to see if they ever really taught you guys this. This is 1, 1, and root 2 in a 45. They're always in that relationship. Okay, we'll talk more about those later on. Okay, it's been a while. I got it. You're freshman year, right? So 2 years ago you were doing this. All right, anyway, that's your right triangle relationships. And so what you would say is you would say sine of 30 degrees is what? Sine of 30 degrees would be, look at this triangle right here. SOHCAHTOA. Opposite over hypotenuse. Here's 30 degrees. It's Friday before a snow day. 1 over. There, oh man, you guys are full of lunch or something. This might not be the best time to introduce trig functions. All right, so sine of 30 degrees would be 1/2. Sine of 30 degrees would be 1/2 because a triangle, no matter how big, the sides will always be in this ratio. It could be 2, 4, and 2 root 3, or it could be 3, 6, and 3 root 3, but it's always going to be in that proportion as the triangle grows, okay? So sine of 30 is always going to equal 1/2. It's always the opposite side over the adjacent side, and this side is always going to be half as much as the hypotenuse, okay, in the 30-60 triangle. So that's the trig functions. Now, cosecant is how this is pronounced, and here's how it's spelled. Cosecant, this is secant, and this is cotangent. Okay, now we're going to talk on Monday, or whatever our next day is, we're going to talk about their relationship. And actually what they are is they're reciprocals. Okay, so sine pairs with cosecant, cosine pairs with secant, tangent pairs with cotangent. They're reciprocal. So if the sine of 30 degrees is 1 over 2, then the cosecant of 30 degrees would be 2 over 1. Okay, so it's just the SOHCAHTOA flipped. Okay, so sine is opposite over hypotenuse, and so we'll just memorize that sine and cosecant go together, cosine and secant go together, tangent, cotangent go together. Okay? It may be nice if sine and secant, they both start with S, but that's not the way it works. Okay? All right. So anyway, let's talk about unit circle coordinates. All right, so if we have a circle, so this is what we've already talked about. Now, the reason we call it the unit circle because look at the radius. What's the radius here? The radius on my picture, this circle, 1. See the coordinate 1, 0? See the coordinate 0, 1 up there, right? The radius of this circle is 1. So when we talk about the unit circle, what we're talking about is we're talking about a radius of 1. So we're taking a special circle that has a radius of 1. So we will be working all year long here, most of the year, anytime we're doing trig, a big part of what we will be doing is talking about the unit circle. So all these circular wheels and all this stuff we've been talking about, right, in linear speed and so forth, when it comes to the trig functions, we're going to think of it as a unit circle. Now, I went ahead and drew a triangle in there because you've already been exposed to the trig functions as triangle relationships, SOHCAHTOA. So if we look at this, so first of all, we know theta is S over R. Now, we're all in radians right now. Everything we're going to do right now is all radians. Now, in your mind, you might convert, to help you a little bit. We still do that a little bit, but we're in radians. So theta is S over R, but if R is 1, theta is just S. So the angle and the arc length here are the same thing. The angle and the arc length is the same thing. Okay? So our radian angle and this, if that's in inches, it'd be the same thing. So if this is pi 6, which is about 0.5, right? 3.14 divided by 6. If this is pi 6, about 30 degrees, that'd be 0.5 radians, and this would be 0.5 inches right here, right? This length. Because if we were measuring this in inches and this radius was 1 inch, our S and our theta would be equal. But again, back to this, that's only true when the radius is 1. That's what's special about the unit circle. Now, this triangle, then, this hypotenuse would be 1, right? Because that's also the radius. So the hypotenuse would be 1. So SOHCAHTOA would tell us sine of theta would be y. This is the y. So if I take a point on the unit circle, call it xy, right? I don't know what it is, so we'll just call it xy. If you look at your right triangle, the x-coordinate is this side of the triangle, and the y-coordinate's this side of the triangle, right? So sine would be opposite over hypotenuse, y over 1. Well, that's just y. Interesting. So this y-coordinate right here is the sine of that angle. Same with cosine. Cosine is adjacent over hypotenuse. X over 1. Again, that would only be true in the unit circle. Otherwise, this would be y over r. This would be x over r, right? But when the radius is 1, it's really, it's helpful to us. So x, so cosine theta is equal to x. In other words, this x-coordinate is the cosine of that angle, okay? So what we've just learned is all of the points around a unit circle, those values are the cosine and the sine of whatever angle creates that point on the unit circle. Okay? All right, and then of course tangent is just y over x. Tangent is opposite over adjacent, and that's true in any circle. Now, keep in mind, I want to show you a picture. You don't have to write this picture. That wouldn't be a bad one to write. But this picture. Now, remember, we talked about a lot of different circles. Let's imagine the green one is the one where the radius is 1. Okay? So remember, you got bigger circles. The angle stays the same, but the S doesn't, right? The arc length gets bigger as the circle gets bigger, right? Only in the green one, only when R is 1, is the arc length the same number as the angle. Again, we're in radians. So if this was pi 6, 3.14 divided by 6 is about 0.5. If this angle was 0.5 radians, it would be 0.5 radians in the blue circle, it would be 0.5 radians in the green circle, it would be 0.5 radians in the red circle. That angle is the same in all of those. It's 0.5 radians. Only one of these arc lengths would be 0.5 inches, the green one, the one that's in the unit circle, the one where r is 1. Only in that case is theta the same as the arc length. So just trying to build a case of why we have this thing called the unit circle. Okay? All right. So we had S equals r theta again, right? But if the r is 1, S is equal to theta. The arc length is the same as the angle. All right, now, this page is exactly the same as the last page you wrote down. But what have I changed? It's in red. Instead of S here, you're right. Everywhere else it replaced what? Theta, right? Theta. Now, a lot of times we use Greek letters for angles, okay? But now we want to talk about the trig functions, like f of x, right? Our first quiz was about functions, like f of x or g of x, and x is our input, right? And so theta could be our variable, theta could be our input, but typically we just use letters like x or t. So for this, we're going to usually use t. Now, the reason we're going to use t and not x is we're already using x for something else. We're already using x and y as the points around this circle, so I can't use x for my angle. So I'm going to use t, and theta starts with a t, so that's convenient. Okay? So a lot of the time we'll use t. So when you see that in the problems, think theta. But remember, it's just a number. Since we're in radian measure, this is the advantage of radian measure. We're not stuck to this arbitrary 360 degree thing. We can use actual numbers, real numbers that are like pi is 3.14, right? 1 radian, 2 radians, whatever. Okay, so that's all I did there. So that's all that looks like. All right, so, and then this just repeats what I wrote over there in the red. Okay, I just said, okay, so what we just found out is if we're on the unit circle, then cosine and sine are the x and y coordinates at that point. Cosine and sine are the x and y coordinates at that point. What you'll hear me say a lot over the next week or so, sine is y. That's how you remember it. Well, a couple ways you remember it. C comes before S alphabetically, X comes before Y alphabetically, so cosine sine. Sine rhymes with Y, so sine is the Y, cosine is the X, whatever. But that's something you want to leave this class knowing for sure. It's one of the first things I ask my calc classes. X is cosine, so Y is sine when it comes to the unit circle. All right, so on that piece of paper that you guys have, okay, we're going to fill this in. All right, now, so going this way, what do you suppose this first dot is? What angle is this first dot? 30 degrees or, yeah. Oh, right. 30 degrees or pi over 6. Now let's do it in radians, okay? 30 degrees or pi over 6. What's the next one? I shouldn't even have it up here. I'm going to take it in. Okay? 30 degrees or pi over 6. Next one? Pi over 4. Next one? Pi over 3. Now write them on the inside like I am because we're going to write something else on the outside. Sorry. Write them on the inside of the circle because we're going to write something else on the outside. Pi over 6, pi over 4, pi over 3. We are now beginning the process of memorizing this. Probably what I'll do is for several days in a row, I'll hand you a blank one of these and I'll have you fill it out. Right? Just for practice, kind of warm. Okay? Because we really want to commit this to memory. Okay? Pi over 6, pi over 4, pi over 3. Now what's this one? I didn't label a dot on it, but let's label this up here. What's that? Pi halves. 180 over 2 is 90 degrees. Pi over 2. Next one. 2 pi over 3. Okay? Now maybe it's easier. I don't know what's easier. Maybe it's easier to do this. How about this? The one in the middle here is pi over 4. Let's just stick with that one. That's 45 degrees. Another 45 degrees is here. That's 2 pi over 4. Now what's this middle one? 3 pi over 4. What would come next? What's after 3 pi over 4? No, okay. Let's just, I'm sorry, I'm jumping around here. Okay, let's stick with the pi over 4s right now. 1 pi over 4 was here. 2 pi over 4 is here, which reduces to pi over 2. 3 pi over 4 is here. What's next? 4 pi over 4, which would be pi. Then what's next? Oops, I put that on the outside. Pi. What's next? 5 pi over 4. What's next? Where's 6 pi over 4? Right here. 3 pi over 2. 6 pi over 4 reduces to 3 pi over 2, which is 270 degrees. What's next? 7 pi over 4, which would be that middle one. And then what's next? 8 pi over 4, which is 2 pi. And of course, we started that at 0. See what I did there? Okay, now let's do pi over 6. So this first one's pi over 6. What's next? 2 pi over 6. Just count, right? 1 pi over 6. What's next? 2 pi over 6. Well, that'd be pi thirds. What's after 2 pi over 6? 3 pi over 6. Well, that's pi halves. What's next? 4 pi over 6. That's 2 pi thirds. What's next? 5 pi over 6. That's this one. Right? What's next? 6 pi over 6. That's pi. What's next? 7 pi over 6. That's that one. What's next? 8 pi over 6, which would be 4 pi over 3. That's that one, right? Because these are each 30 degrees that we're going here by pi over 6. That's 4 pi over 3. What's next? That was 8 pi over 6. 9 pi over 6 would be this one, right? That's 3 pi over 2. What's next? 10 pi over 6 would be 5 pi over 3, right? 10 over 6 would be 5 over 3. And then 10 pi over 6, 11 pi over 6, and then 12 pi over 6, which is 2 pi. And now we got them all. Now we got them all. So I don't know, whatever works for you, but right, we want to be able to fill those in. Fill those in. Some people remember the ones down here near the bottom are the thirds. Here, the ones closest to the x's are the sixths. The ones in the middle are always the fourths. I don't know. Whatever works for you to try to memorize those. Okay, and then we've done this before. We've already talked about that. But here's the new thing we're going to do. Here's a new thing we're going to do. Okay, so we all know this is the point 1, 0. So on your picture, I'm going to change colors here. Put 1, 0. Because clearly that is the coordinates of that point. This point is 0, 1. So that's easy to know. This point over here is negative 1, 0. We know that because of the, and this is 0, negative 1. Right? Okay, so I'm going to pick up the pace here a little bit because we're going to run out of time. All right, so we know those points. What we want to do is we want to label these points. What would be the coordinates of these points? Well, we're going to get a little help here. And we're going to go to 30 degrees. And it's that. Now, why is it that? SOHCAHTOA. Okay, and remember what we said right here. Look over here now. See right here? Now they're using theta, but didn't we say that a minute ago? Cosine was the x, and sine was the y, right? Did we say that a minute ago? Right? Cosine is adjacent over hypotenuse, x over 1. Sine is opposite over hypotenuse, y over 1. Look at this point. Remember what I told you from geometry? Remember this was square root of 3, and this was 1, and this was 2. Just forget the 1. I know the hypotenuse is supposed to be 1, but just your geometry relationship, remember that? What's the sine of 30 degrees? It's opposite over hypotenuse, 1/2. What's the cosine of 30 degrees? It's the adjacent over hypotenuse, square root of 3 over 2. So it doesn't make sense that that's what those coordinates would be. Now, square root of 3 over 2, if you look on your calculator, is about 0.866. Square root of 3 over 2 is about 0.866. How far does it look like we're over here? 1, 2, 3, 4, 0.5, 0.6, 0.7, 0.8. Does that look like about 0.866? Okay, how far up? Looks like about 0.5, right? So it's about 0.866 over 0.5 up. What does that mean? What that means is the sine, and this is stuff we will memorize. We're going to memorize these coordinates, and then what we'll be able to do is I'll be able to come up to you in the hall, and I'll say, hey, Corbin, what's sine of pi 6? And you're going to say what?
Square root of 3 over 2.
No. 1/2. Sine of pi 6 is 1/2. Why? Because sine is the y. Sine is the y, cosine is the x. So sine of pi 6 is 1/2. This is what your homework's going to be. So it's going to give you pi 6. It's going to ask you for the sine, the cosine, the tangent. Well, you're going to have all the coordinates right in front of you because we're going to put them on the thing here. Okay, so write that. Now I'm not going to go back to this picture every time. But now, right here, put square root of 3 over 2, 1/2. That's the coordinate of that point on the unit circle. And we're going to memorize that. We're going to know that that's what that point is. Okay? All right. Now, you write them just like that. I'm going to just go around this thing. Okay, so let's go to 45 or pi fourths. Square root of 2 over 2, square root of 2 over 2. Does it make sense they be the same? Cosine's the x, sine's the y. Cosine's the x, sine's the y. Does it make sense that the x and y are the same in a 45-45? It's isosceles triangle. Those two are the same. Okay, they're square root of 2 over 2. That's about 0.707. Square root of 2 over 2 is about 0.707. Square root of 2 is 1.414. Okay, divide that by 2 is about 0.7. That's what it looks like. 0.5, 0.6, 0.7, little past 0.7. Go up, little past 0.7. A little higher than that other point. So the y value's bigger. Makes sense. Okay? All right. Keep going. Let's go up to, whoops. Let's go up to pi thirds. Look at that. They're just reversed. Oh, that makes sense. Remember the 30-60 triangle? We were in the 30, right? And the 1 was opposite and the root 3 was adjacent. But when you go to the 60, what happens? When you go to the 60, what happens? Now the 1's here. Now the 1's adjacent because it's across from the 30 and the root 3's over here. It's across from the 60. So the root 3 is opposite. So opposite over hypotenuse, right? That kind of thing. All right? So they're just flip-flop from the 30. Makes sense that the x would be smaller. We're only going over 0.5. We're not going over as far. We're only going over 0.5 and we're going up farther because it's higher. Makes sense that the y would be bigger. Okay, let's keep going. Go to pi halves. Of course, we already know that one, 0, 1. Now let's go to 120 or 2 pi thirds. Look at that. Does it make sense? It's the same exact point as this one over here, except what? Doesn't it make sense in quadrant 2 the x would be negative? Quadrant 2 the x would be negative, but the y is still positive. So it's not like we got to memorize a whole batch of numbers. We just got to remember a few. We just got to really remember the first coordinate numbers or the first quadrant numbers, and then the rest are just going to be different depending on their sign, depending on what quadrant they're in. You can probably fill in the rest, right? 3 pi fourths. The x is going to be negative. In this quadrant, the x will have to be negative, but the y will be positive. Okay? Negative root 2 over 2 and root 2 over 2. Okay, go down to the next one. Okay? It's going to be the same as pi 6 was. It's going to be the same point that 30 degrees was. Same y value, and the x is just negative. Okay? So we already know pi is negative 1, 0. So we keep going. Now what's going to happen in quadrant 3? Both negative. So now this point's going to be exactly the same point as 30 degrees, exactly the same point as the one across from it, 30 degrees, but they're both negative. They're both negative. You go to 5 pi fourths, again, they're both negative. In this quadrant, they're both going to be negative. And down to 4 pi thirds, that's going to be the same as pi thirds, but they're both negative. You can't even see it. Sorry, it's off the thing, but you got it. Okay, and then around to 3 pi halves. We call these the quadrantal angles. Quadrantal means they land right on a quadrant, an axis. Okay, so there's not a triangle that's formed when you're on one of these. Okay, so when they land right on 90 or 270 or 180. Okay, and then quickly going around, okay, this one. Now the x's are positive, right? So this is the same point as this one here. Okay, but the x is positive. The y is still negative down in quadrant 4. Okay, and then around here, again, the x is positive, y is negative. and over to there. Okay, same x is 30 degrees, but the y is negative. So you can see why it won't be awful. And don't shut things up just yet. Here's what your homework will be. Like I said, it's about 10 problems or 6 or 8. I don't know. It's really quick. It looks like this. So you have that thing in front of you now. So leave it set right there in front of you. Okay, here's what the homework will look like. So it'll say 5 pi thirds. Write the sine, write the cosine, write the tangent, if possible. Sine is the y. So you're going to go over here to 5 pi thirds, which is down here. What's the y? Negative root 3 over 2, isn't it? Right down here. So that's what you write, negative root 3 over 2. Cosine is the x. What's that? 1/2. Now, what do we got to do with tangent? Remember, tangent was y over x. So we have to take our y divided by our x. 1/2, no. Negative root 3 over 2 divided by 1/2. How do you do that? Well, you can use a calculator if you want. Well, I don't want a decimal, so don't use a calculator. I want to leave it in radical form. What are we going to do? Just flip this up, right? So we'll flip that up times by 2. Well, the 2's will cancel. What do you get? Flip this up, 2 over 1. It's negative root 3. Negative root 3. So those are your answers for sine, cosine, and tangent. Negative 5 pi fourths. Now, where would that be? Now you have to think a little bit. Negative 5 pi fourths. You go this way, that'd be negative 4 pi fourths would be here. That's negative pi. How much farther I got to go? Right to there. That's actually going to be, that is going to be negative 5 pi fourths. Is going to be right there. Okay, so whatever those points are, take the y for sine, take the x for cosine, and then y divided by x is the tangent. That's all you got to do. So you got the numbers right in front of you to use. Okay, it's the homework is right there. So 17, it looks like 10 problems. 17 through 26 on 297 is doing what I just showed you on that last problem there. So it's just getting your x and y coordinates off that picture you have in the unit circle, and then finish up by problem. And that we will hand it in at the beginning of class. Okay.
So sine is x.
No, sine rhymes with y. Sine and y rhyme. Or how about this? Cosine and sine. C comes before S in the alphabet. X comes before y in the alphabet. Okay? One way or the other. But cosine is the x, sine is the y.
I calculated it. And the ones that I didn't know how to do, I calculated. No, we're doing very good now. How much is stress? I'm serious, I'm gonna take like the bite of it and be like, so.
On the quiz or the test for like the story problems, were we supposed to put it in terms of pi?
Well, it depends. It seems like one of them it said, but it depends what the directions are. If they didn't, it doesn't matter. 6 wasn't really a story problem. The hands of the clock said leave answers in terms of pi. 5, the one with the CD, said leave answers in terms of pi. So 2 of them it did, yeah.
Okay. I don't think I put either of them in terms of
Okay, well, it might have cost you. They were worth 3 each. Follow the direct. Yeah, if it specifically says it, you should do it.
That's too great. I think if we have that done in class, the worksheet. Yeah, we didn't have any.
What? Anne's here today?
Is that?
Do you know
She
what
is
it is?
not. Well, at least according to the computer, she's not.
Uh,